Hi, kids. All right, we have a graph here, magnetic field measured in Teslas, time measures in seconds. And we have a 30 centimeter by 40 centimeter loop. It's in the changing magnetic field. We want to determine the voltage induced for each interval. And just so we know, the loop and the field are always pointing the same direction. So this should be, you guys should be thinking about Faraday's law with this. So make sure we can see this. Okay, so there's Faraday's law. From 0 to 2 seconds. Okay, if we want to find our voltage, you're going to say we have one loop, so because it's a loop. To find the change in flux, we're going to go final minus initial. So if I want to find my flux, I need to go BA cosine theta. So my change in B is going to be 4, so B, and then my A is 0.3 times 0.4, and then cosine theta is going to be 0, so that's 1, so I'm not going to worry about that, divided by the time, so that's 2 seconds. So again, I want to make sure you guys understand where I get the 4, because it's the change in flux. So my B ends at 2, it starts at -2, so my change in B is going to be 4, and then BA, and then cosine theta is 1 over 2. So I do the math, and you get, let's see, 4 times 0.3 times 0.4 divided by 2. I get 0.24. So negative 0.24 volts. From there, from 2 to 4 seconds, there's going to be no change in B, therefore no change in flux, therefore no voltage induced. So I don't have to worry about that part. And then from 4 to 6, okay, we're going to go -1, because again, a loop. I want to go my change in B. My final B is 0. My initial B is 2. So my change in B is -2 Teslas times 0.3 times 0.4 divided by 2 seconds. And you do the math there. And you get positive 0.12 volts. So from 4 to 6 seconds, it's positive 0.12. From 0 to 2, it's negative 0.24. Now remember that positive negative means that if you had current flowing in your loop, so if I gave you a resistance, that the current would be flowing opposite directions for each of those two things. So there you go.